Hello, good morning. My name is Riba, and I'm going to present the last contributions on graph neural networks for document image analysis that I've been working on. The two works that I'm going to present, I've been working during the last couple of months to prepare submission to a journal. The first one is about learning graph distances, or how we can compare graphs. You know that from a few years ago, graph neural networks have become really popular in the machine learning community, but still only few works were focused on how to compare them. If we look in traditional approaches, graph edit distance was one of the main frameworks that appears at the time, and a lot of approximations of it, as the time complexity is very high, also appeared. What we propose in this work is to take one of those approximations and try to adapt to these new graph neural network frameworks. More precisely, the framework that we have chosen is the How to Edit Distance. And why we want to do this, and what we have that other approaches didn't have. So first of all, here we present a triplet network, but we are avoiding graph embedding, which have a lot of structural information, and that most of the frameworks use. Moreover, a recent work from Google, what they propose is to have edges connecting the two graphs that we are comparing, but this adds a huge complexity to the problem in terms of time. What we propose here is, okay, let's have a graph neural network that will learn some features on the nodes of the graph, and let's compare them directly without going to an embedding nor having connections between them. So we have seen that we have results that match the state of the art, and we are avoiding these steps. Moreover, in our framework, what we can have is the node-to-node correspondence, or which node goes to which one, and also which nodes has to be deleted and which ones have to be inserted. For instance, here we have two cases where the first one, they are graphs belonging to the same class, the second one are graphs belonging to different class, and you can see that the bottom one have more connections in diagonal that are costly substitutions, and also have more insertions and deletions. The second work that I'm going to talk is about anonymized table detections in invoice documents. Administrative documents are a really hot topic in document image analysis, and I would say in computer vision, even though it is more done in companies rather than in conferences. So the big issue here is why we want this to be anonymized. It's because invoices contain a lot of sensitive contents, and our industrial collaborator, that is, in this case is Omnius, had this concern and wanted to see if we can perform quite good without having these visual cues. So what we propose is a graph neural network that we have a prediction for edges, a prediction for nodes, that try to detect whether they belong to a table or not. Moreover, as we have seen that it can lead to some discrepancies in terms of the edges and nodes, we had a consensus layer based on belief propagation at the end. So this is the problem, and the bottom line is the results of our framework in the completely anonymized way, and the first line is the ground truth. If you look at the second column, we can see that we have 4 tables in the bottom that are just detected as one. But if we only look at the structural information, humans even will just detect one table rather than 4. And what is missing to match the ground truth here is, I would say, the visual cues, such as color, lines, etc. So finally, as my personal challenge for the next few months is just to prepare my thesis defense, as I have submitted the thesis 1 month ago. So I hope that you find this interesting, and you can ask questions if you like. See you.